Silo calculations, laminate thickness. Now that we have the geometry and the loads, we are ready to build a product. As we go through filling in each section, remember that you can always refer to the drawings for help. Start by navigating to the laminate thickness page. You can reach this page by clicking on the laminate thickness heading right at the top here. This page is related to everything regarding the laminates, so let's start by filling out some general data. We need to start by selecting the resin that will be used. In this case, the orthopolyester that we added to our materials list in an earlier tutorial. Then we need to indicate whether or not the silo will be tempered, that's heat treated, afterwards. Next, we need to indicate whether or not the silo will be insulated. On the drop-down, the option is, of course, yes or no. If you put yes, however, please remember that this will add some weight to the silo, which will be taken into account for the structural calculations later on. Now for the A2 factor. According to N13121 standards, this is the factor for chemical resistance, which depends on which type of product you will insert into your silo. You can get this factor from the Chemical Resistance Guide or get resin advice from your supplier. Mainly for silos, you can leave it on 1 because solid particulates don't have a lot of chemical influence on the wall. The type of chemical protection for solid particulates, in this case, will be SPL, the single protective layer. It's usually enough and has a thickness of about 0.5 millimeters. Again, refer to the EN standard if you're not sure. Then we build up thicknesses. The cover, for example, has 2 areas, the crown and the knuckle. The crown is the center area, and the knuckle area connects the crown to the cylinder wall. Most producers actually build up the crown and the knuckle in the same thicknesses. You need to enter the number of modules, which refers to the number of layers you build up. We enter that right here. Based on your material properties, the thicknesses is automatically generated here. This depends on the module thicknesses you filled in the materials list. The length of reinforcement will be calculated automatically later, so don't worry about that. Now on to the cylinder. You can see that Amphora has actually chopped up our cylinder into different slices. If you'd want less slices, you can enter equal thicknesses for your slices that are next to each other. In this case, we don't, so we need to make sure that we've entered it accordingly. After filling out information on the cylinder, we need to enter information about the hopper bottom, which can be quite tricky in terms of thicknesses. We'll start by filling out the crown thickness. So on the drawing, if you're a bit confused, that's the TB right here. Then the knuckle thicknesses, that's going to be TE right here. The cylinder, which is TZ, and crown 2, which is TBK. So make sure that you filled in the number of modules for each the section of the hopper. After that, we need to fill in the support and anchoring for uplift. This will depend on the type of support you selected earlier in the geometry page. For our skirt, we need to enter a number of modules for the skirt upper part, and the skirt lower part. Great. And for anchoring for uplift in this particular silo, it's not something that we have to fill in. But again, this does depend on type of support that you selected earlier in your geometry calculations. Now, check to make sure everything has been filled in correctly on this page and click to Update to save your changes. This makes sure that your most recent entries have been saved and so that you're ready to make your report. Go back to the top of the page. You'll see the button Evaluate. By clicking on the Evaluate button, the first preliminary report is generated. Check out our next tutorial to learn how to interpret your report.